Okay, so we've got our new plugs in, we've got our new points and condenser, we've taken a quick look at our distributor cap and wires. Everything looks relatively well. Probably the next thing we want to do is change the fuel filter. Again, sometimes you have a clear glass one, sometimes it's a clear plastic one, sometimes you can't see it, but it's cheap insurance. They're very cheap, and I would put a fuel filter on, particularly in a car like this, because you don't know what condition the gas tank is in. Was the gas tank restored? Was the gas tank taken out and cleaned? You have no idea what the inside of that tank is like. What I do in a lot of cases, if I suspect anything, take the fuel filter off and cut it apart. Take a look at it. If you can't see it, take a look and see what's in there. I've also done that with oil filters. Taking them apart because I see something that just doesn't look right. Well, if there's metal pieces or stuff that just are popping up in the oil or anything like that, when you drain the oil, all of a sudden you see some metal particles in that drain pan that shouldn't be there. First thing I do is I take the oil filter off and I cut it apart. And it's all these rippling, you can pull it right out like an accordion, and you can get a heck of an idea what's going through that, or not going through that filter that's being caught in there. So again, getting back to it, I would always change the fuel filter on a tune-up. So we've got the parts back in, fuel filter on, everything's set. We hook up our battery and everything again, and we're ready to go. Before you do that, go down to your timing marks, which are on your pulley. And what I always do is I take one of these old touch-up paint sticks, and I will actually mark the timing marks on the pulley and on the little, however it's set up, a little tab, and there'll be a mark on your harmonic balancer on your front pulley there. And I will mark it so it's just a little bit more visible with a white paint stick. And it'll stay there forever. And remember, in the old days, you tuned these up about every 10,000 miles. So you were in there a lot if you kept the car a few years. So, or in some cases, use a piece of chalk. On some of the older cars, the timing mark will be back on the flywheel. And it will be visible through a little hole like this in the bell housing. Again, you can get in there and put a little mark on it. You'll have to turn the engine over till you get top dead center on number 1 piston cylinder, and then you can find it. But some will be back there, some will be up here. At that point, hook up a timing light, and this is an induction timing light. This goes on number 1 plug wire. This goes over to your battery, and you're pretty much good to go there. You can also set up, if you just threw the points in and it looks okay, and instead of going with a point gap at say 18,000th of an inch, you're going to set the dwell. And the dwell is the time that the points are open versus when they're closed, how much that rotor turns or that distributor turns. And in a lot of books, particularly GM, they won't even give you a point gap. They'll give you a dwell reading. So what you want to do then is take any kind of a dwell meter. Here's a handheld dwell meter. Here's another one here, and here's a bigger, older one here. And hook that up, and usually they go to the coil and to the battery. And you've got these 2 items hooked up, start your car. First thing you want to do is check that dwell angle. Now you've put the points in that say they're gapped at 18, 20, you know you're good to go there, but you may have to tweak it just a little bit to get the dwell. Now on the GM ones, it's great because you can go through a little window on a distributor cap with an Allen wrench, and you can adjust the gap on these points while the engine's running. It's fantastic. They made a little special flexible tool for that. If you find that you can't get the right dwell angle, you may have to take the distributor cap off, either open the plug or the points up a little bit or close that gap to get the right dwell angle. Once you've got that set and you know your distributor is okay, then check your timing, because every time you change those points, you change the timing. So your engine's running now, start it up, and just aim this down at your damper, and this will fire a light every time number 1 plug fires. And you can set it and you can watch it. You can loosen up your distributor, you can turn it and move that timing mark up and down the scale. Another thing you can do while it's running is pull your vacuum advance off. Now some cars will have you set the timing with the vacuum advance hooked up. Some cars will have you disconnect it. Some cars won't even have a vacuum advance. They only have mechanical advance. And again, we're talking the older cars. Some will tell you block this off before you even start it. Others will tell you you can hook it up then, and when you hook this back up, you get your initial timing set at, say, top dead center, 10 degrees before top dead center. Then you hook up your line, and you can watch that timing mark with your timer. It might jump up to 15, 18 degrees. Then as you race the engine up, these weights will fly out. This is your mechanical advance, and this could be mounted up here, or it could be underneath. You'll see the timing go up even farther, because believe it or not, timing and explosions in that car engine take time. They sound instant, but at 6,000 RPM, things are happening pretty quick. So you've got to advance that timing so that explosion is hitting at the right time. So technically what you're doing is you're setting that plug up to fire 18 degrees of crankshaft rotation and piston travel before top dead center, because it takes time. It's not as instant as you think it is. And at that RPM, things are happening so quick, if you wait and fired it at top dead center or after, this engine would run very, very poorly, plus it would overheat. It would start running hotter. Late ignition timing. Overheating is a great indicator of late ignition timing. So as quickly as things are happening with an explosion, it still takes time to do that explosion and get that piston driving down. So you're actually firing the plug. The piston's coming up so fast, you're firing the plug before it even gets to top dead center, but by the time it gets there, the explosion is fully involved and it's going to drive the piston back down on the power stroke. So, but again, you can check this again. If you didn't check it with the vacuum tester, you can check it right here just by putting it on and off and on and off. And as I say, some, I believe, these small block Chevys, you blocked off the vacuum port on the carburetor, you set your timing, initial timing, then you plug this in, and it gave you the timing needed for proper running. So different ways you can check your advance system. You can watch it right there and very, very clearly, and if you've got a good mark on that damper, you can see it real well with that paint. So again, you've checked a few more things without really getting into a lot of heavy repairs. So we've got, our dwell is good, our point gap is good, everything's running smoothly, our timing is good, engine's running a little rough. Well, maybe we've got to check the mixture on the carburetor. And is it adjusted properly? Is it too rich? Is it too lean? So you've got your air cleaner off. And again, on a normal tune-up, check the air filter too. If it looks dirty, replace it. Don't try to blow it out. Don't try to shake it. Throw it away and put in a new air filter. All you're doing is shaking stuff loose in that filter, and you think you got it clean, you put it back in the air cleaner, you put it on, you start the engine up. A lot of those particles were shaken loose, and now they're going to be sucked right into the engine. So don't try to knock them out or shake them out or blow them out. Get rid of it. Put a new clean one in. In regards to that, a dirty air filter will cut down on the amount of air going in the carburetor, which is going to increase the amount of fuel ratio. In other words, instead of it being 15 parts air to 1 part gas, now you're maybe down 11, 10, 9. So the fuel mixture is getting rich. The rich mixture is going into the cylinders. It's going to cause wear. It's going to dilute the oil a little bit because you've got a rich mixture all the time. It's going to fall out the spark plugs. So clean air cleaners are a cheap insurance against things like that. So basically what we want to do then is we've got this engine running. Most of these dwell meters, if you still have them hooked up, are a combination tachometer and dwell meter. So what we're going to do is we're going to go to the adjustment screws on the base of the carburetor. This is a 1 barrel that only have 1 screw. And we're going to see what the engine RPM should be set at. Try to get it around there wherever you want with your throttle stop. And then turn in that mixture screw until the engine starts to falter, then back it out. And you can do this by ear, or you can watch the tachometer on your gauge. And the whole idea is you want to get the highest RPM you can get out of that car at idle by adjusting that screw. And also the smoothness of the engine. If it's too lean, you turn it in too far, you're shutting the fuel off, it'll start to shudder and shake. If you back it out, the same thing is going to happen. So you want to get the nicest idle you can, smooth idle, on your tachometer that you can possibly get. Once you get that, everything seems great. So the manufacturer says, well, it should be set at 750 RPM. Then take your throttle adjustment screw and dial it up to the recommended, whatever's recommended in the book, 750, 800. In the case of an automatic car, it might be a little higher because when you pull it in the gear, it's going to load the engine a little bit more. So again, basically, if you can't get the carburetor adjusted, it means we've got something internally wrong in the carburetor. It can be rebuilt. You don't have to buy a new one. 9 times out of 10, it's only a little bit of dirt. You can rebuild the carburetor. Very simple job. But again, this will help you adjust the carburetor. Another way you can adjust the carburetor is with a vacuum gauge. This engine, running properly at idle, should have about 20 inches of vacuum. In fact, some of the manufacturers used to put these on the dashboards and call them economy gauges, because the minute you put your foot in it, the vacuum drops and you accelerate, and they would have low gas mileage or high gas mileage. And this would actually be, Pontiac had these actually on the dashboard. I have a brand new Accord, and it has something very similar to this. It's a mileage gauge on the dashboard, but it's a little electronic scale. The more you put your foot into it, it goes to the 0 mileage, miles per gallon side. So it's nothing new. It's electronic in that car. But this is a vacuum gauge, and you want to get this thing at idle at a good 20 inches of vacuum, nice steady needle. If the needle's fluttering, it could be 100 things. It could be a leaky valve. It could be worn rings. It could be a vacuum leak between the carburetor and the manifold. It could be a leak between the manifold and the block. But if you put this on there, for some reason you weren't getting this adjusted right, it was still idling, and you've got this fluttering back and forth, you got a vacuum leak somewhere. Someplace there's something isn't quite right. Could be a worn valve, could be a valve that's not sitting right, and what's happening is the vacuum in the manifold is not constant. It's not being sucked through constantly. It's fluctuating. And this here will tell you a lot. It can tell you too much.